Alright, hello everyone. This is my first attempt at creating kind of a video blog type of thing, and what I'd like to do is kind of document a project I am undertaking. This is a Kilowatt by P3 International, which you may be familiar with. If not, it's a inexpensive, I'll say, plug-in watt-hour totalizer slash ammeter type thing. Basically, you plug this in, and then you plug whatever you want into it up to, what's this rated for anyway? 15 amps, 1800 watts, which is pretty good. You can put an air conditioner on this, for example. Small through-the-wall air conditioner, anyway. And this will tell you various things about it. Volts, amps, watts. It'll do volt amps and power factor, which is interesting. I don't know how useful that actually is. But it has a totalizer in it. So that's actually kind of useful. The problem is, when you have this plugged in, it's usually in a wall outlet, which is down low and maybe not in the most accessible of places. And it's really hard to read because this is not a backlit LCD screen. It's just a regular LCD element. And as soon as you unplug it, it forgets everything. So you can't like pull it out of the wall, take a look at it, and put it back. So what I'd like to try and do first and foremost is see maybe we can mod a battery into this of some kind. We'll see what kind of power it draws. And the other thing that I was thinking is definitely going to be more difficult to do is to try and get the information out of this somehow. Now, I know this is probably not built to have any kind of serial out or anything fancy like that, but I think what I'm going to have to try to do ultimately, if there's no better way, is to tap into the LCD driver lines with a microcontroller and see if I can decode the signals that are driving the LCD to see what it's displaying. And maybe tie into the buttons somehow to press those. Although really, I guess what I'd really be interested in is the watts and or volt amps. So maybe you could just set it to that mode and run with it. I don't know. We'll find out. But just to show you how it works, I have a power strip here. I'm going to plug it in. And no matter what you do, it's always going to block at least one other plug. So that's another design fault I don't particularly care for. And we'll turn that on. And there's a lot of stuff on that screen which never comes up in normal operation, which tells me that the microcontroller in here probably has a lot more features than this thing lets on. So they probably use the same board for multiple units. There might be units with more buttons or whatever. But this right now is displaying the voltage, which I guess is 108 volts on the line here. I don't know why. Amps, of course, there's no loads, nothing plugged in. Watts, nothing. Volt amps. Hertz, 60 hertz, right on the money, and power factor of 1, which I don't know if it's measuring its own power supply for the power factor or not. I'm not 100% sure how it's powering itself. There's probably, no, there's definitely some kind of voltage drop and rectifier and whatever in there. Because it weighs almost nothing. There's no transformer in here, guaranteed. And then there's the totalizer, which of course is not totalizing anything. There's a timer there. And this is kind of what you'd be most interested in if you're trying to figure out how much energy your appliances use. You'd want to know the totalizer, but again, if this is someplace not quite accessible, you really can't use it because as soon as you turn the power off, it forgets what it was doing. So that's not so good. I do have a dummy load handy. Thought ahead. This is just it's actually a laminating machine. So I'll plug that in, and immediately we see that the voltage is dropped. In fact, let me turn that off. Should come back up. Not the fastest responding thing ever, but it doesn't have to be. We'll turn that back on, and we'll see maybe about a 2 or 3 second delay, which isn't too bad. Again, this is not intended to be like a multimeter or real-time thing. It's something you plug in and you leave there for a while, and it records the data for you. But again, it forgets it as soon as you unplug it. So this is 1.64 amps. Okay, that's not too bad. Watts, 190 watts. 190 volt amps. That means our power factor is going to be 1. There it is. And that's a little suspicious to me because I know there is a motor in this device. It's a very small one, granted, but maybe. And it's going to take a while for the kilowatt hours, especially at 200 watts. It's going to take at least 30 minutes for that to become a 1, right? So we're not going to wait for that. But anyway, that's how it works. It's a very simple device. Turn that off. This is brand new, by the way, so all the plugs are nice and tight. Alright, let's get this out of the way. Just drop it on the floor behind me, that's fine. And let's crack this sucker open. Just 3 small Phillips head screws. Okay. How's the lighting, by the way? The lighting for this shot was probably the hardest thing, trying to set up something that I can record video of bench work with. And getting good lighting that's both comfortable for me with glare and everything, and good for the camera with glare and everything is... There's a bright spot right here, and anything shiny that I put there, like a piece of plastic or something, it just wrecks the shot. It's terrible. Okay. That's a messy blob of solder. It's not even like all that consistent. Now this was plugged in recently, so I don't want to go poking it with my fingers right away because there might be a charged capacitor in there somewhere. There's a big capacitor right there, which I'm guessing is probably going to be the capacitive dropper that runs the power supply for the electronics, because there's definitely no transformer in here. I don't know if you can see. There's not a hell of a lot in there. Alright. This looks like it's safe to pluck out. Okay. Cool. And there she is. Alright, we got a current shunt there. That must be how it's measuring the current. And let's see, 1, 2, 3, 4, 5, 6 lines here. So we probably have 2 lines measuring the voltage across the current shunt. That's your current sense. And 2 lines for voltage sense and 2 lines for power supply. That's going to be my guess. I wonder which 2 are the power supply, because that's going to be what I'm interested in. There's not much on this board that would really... I'm going to have to map this whole thing out to figure out what the hell it is that's going on here. Looks like... This is weird here. We got 2 diodes sort of in opposite directions. I guess they're tied into 2 different lines on the ribbon cable, but they're tied together at one end. So that looks like... That's like a half-wave rectifier. But... Okay. Sure, why not? Okay, so this is definitely a capacitive dropper. So if we track this back, that goes into the resistor. The resistor goes... Oh, okay, I see it. There's a trace that goes back underneath the resistor on the top side, and that goes to the capacitor. So I'm going to say that these 2 diodes make up a half-wave rectifier for the power supply. So these 2 middle pins here, this one goes to the current shunt to what would be the neutral, right? Yep. Okay. So these right here are definitely the power supply. These 2 middle ones here, that's good to know. And I'm going to guess... I mean, it doesn't really matter, but I am curious. Here's your current shunt. You got some traces coming along the top. And it looks like I could follow them just under the edge of this smooth here. And maybe these 2 on the top edge, we'll call it, are the current. And so these 2 here would probably be the voltage sense. Here and here. But there's a lot of smooth right there, so it's really hard to tell. I'm not really that curious about that part. But I'm pretty sure the middle 2 are our power supply line, so that's what we're interested in. There's a big electrolytic cap here. 100 microfarad, 35 volt. That could be a smoothing cap. If that is in fact the power supply, I would expect these 2 middle lines to go across that capacitor. And the presence of these 4 screws here tell me that the LCD is probably held in place just by pressure from the circuit board, and it's probably, because I don't see any through holes either, it's probably one of those conductive rubber strips, which are usually held in place by compression. I'm not sure if that's a good thing or bad thing. If it was a ribbon cable, I would probably have a harder time tying into those lines without destroying something, but I'm not too confident about those zebra strips either. Yep, there it is. Okay, that's good though, because it comes apart nice and easy. That's actually in there. That must be a separate... Oh yeah, it's plastic, so that's going to be a separate piece there. Got some conductive buttons, not a big deal. Put that off to the side. Okay. Well, these buttons here are silkscreened: menu, up, down, enter, and output. So there's definitely, they use this board for more than one model, and there's probably some different programming in here that they can do multiple things. I wonder if there's some way to unlock those features. I have to do a little bit of research. Anyway, the two middle lines here. Yep, they go straight across that electrolytic right here. So these are definitely our power lines. That's good. We got some doohickeys here. This guy here looks maybe like a voltage regulator. 78L05. I'll look that up later. That's probably a voltage regulator. I don't know what these are. These are just transistors and stuff. There's a... Which way is that going? That looks like it's reverse bias to the power supply, so that's probably just a protection diode. If there's a voltage spike or something, this diode will shunt it across, and so it doesn't blow itself up. Which is nice. I don't know if I can get a part number off of that diode. It's really tiny. Alright. So I think we can definitely tie in something power supply wise. I just have to meter across these pins here and see what we're getting for our power. Or do I want to tie in the battery before or after the voltage regulator? Probably before, because I wouldn't have to match the voltage exactly with my battery. If I could be, like if this is a, let's say a 3.3 volt circuit, I can put a lithium cell here, which is like 3.7 volts, and let it regulate it down. And that would be great. And I wouldn't have to screw around with anything else. Or a pair of double A's, which would be 3 volts. I guess I need 3 alkaline cells to get that up to 4.5 volts. And let this regulate it down. That'll be fine. I'm just not sure. This should be DC at this point because you have the electrolytic capacitor here. They're not going to put AC across an electrolytic. That would blow it up. Yeah, I think I can do that. I think I can maybe even tie in across the diode because that's just 2 points on the circuit, right? Maybe, no, maybe not. This diode here looks like it's tied in. No, okay, so it comes across. I'll figure it out. I can definitely do something with this. Maybe I'll just tie it in right at the capacitor points. I'll put some jumper wires out. I'll screw around with that. Okay. As for the LCD, I'm not seeing anything here that's really helpful. There's 3 pads here, 3 vias. I don't know what these are. That says U4, but I'm pretty sure that's for the chip, not for these pads. Because on the back, there's a J1 with a pin 1 marked on it. There is probably, I don't know if this is a programming interface, or let me make sure you can see that. I don't know if this is a programming interface or something. There are 2 very thin traces that run up. Oh, there you go. You can see them right there. They run up, they go underneath this buzzer, but I'm pretty sure they're not connected to the buzzer. So they're kind of on this side of the buzzer. Oh, yeah, here's some vias right here. Let me see if I can angle that so you can get a glimpse at them, maybe. Maybe I can zoom in for you. Hold on a sec. Oh, nice. Very nice. Okay, so you can see a couple of vias right here. And those lead right into the microprocessor, which is underneath this ceramic blob, or this epoxy blob, or whatever that thing is. Alright, and here are LCD driver lines. I guess there's 20 of them because it's silk screened 1 to 20. Balls. Now I looked at the LCD before when you turned on. You can see all that extra stuff that's on there. There's like 70 something elements, so there's some serious multiplexing going on here. And what research I've done on how these work is there'll be like they work in pairs. There's like a differential pair. So let's say track 1 would be plus volts, whatever voltage it runs at. I really don't know. And that'll be plus volts, and then the next one will be, it'll go minus, and that'll drive one of the elements in one direction. And then pad 1 will go to negative volts, and the next pad will go up to a positive volt and drive it the other way. And since the LCD elements have a polarity to them, you can drive 2 different segments, two different elements of the display using those two lines just by flipping the voltage. And there's probably all kinds of wacky stuff going on here. That's going to be a real pain to decode too, if that is definitely the case, because there's only 20 lines and there's 70-something elements on that LCD. All I have is a 2-channel analog scope, so that's going to be real fun to try and pick that up. Maybe I should break down and buy a logic analyzer. I would need one that can do negative voltage too, or unless I got to do some voltage offset, I guess. All right, so that's more research for that. Anyway, I think that's really all I can divine from now. I mean, all these buttons have there's a common trace here with a via that goes right through there, and that via pops out kind of right in the middle of the board, so right here. I don't know if that's a high or a low common, but it is a common. And we got these little pads here, which are probably maybe test points. Although I don't see a little dimple in them, so it doesn't look as though they've had like a pin poked into them to test them. I don't see a dimple. So maybe I can solder a little lead wire onto these pads, and that won't interrupt the buttons on the face of it, but I'll be able to bring those out and control those, maybe some, get some transistors in there and have a microcontroller push the buttons for me. I'm not too confident about how to do this. I'd have to solder some really thin wires onto there. I might have some real thin magnet wire I can put on there that the LCD screen can push down against. Because we got one of these, I can get this out of here. Oops. There you go. You have one of these zebra strip things here, which there's channels of conductive material that run this way, but they're insulated this way. So basically any power that goes in at this particular spot here will come out on the other side. And if I have some thin wires and I press this down on top of it, it hopefully won't screw it up. That's going to be rough. That is a secondary objective to the power supply thing, though, so. Alright, so I think we learned a bit. This is looking like a fun, sarcasm, air quotes, fun project. And, yeah, we'll see where it goes. I just got to figure out how this goes back in the, like that. Back in the case. Alright, let me break out the soldering iron, see what kind of damage I can do. Alright, so I got all the wires soldered on. I think that's going to be okay. What did I use? I used a... what is this? I don't remember what it was. Let's see if I can... just tore the label. What size wire is this? I have a feeling it would be right there where I just ruined the label. Oh well. Anyway, I used this magnet wire. It was the thinnest I had available. And I soldered in all of the pads for there. And I came through this conveniently located... shoot. That's a screw hole. That's fine. I won't put that screw in, that's all. Came in through that hole. And I attached here across the capacitor, which should be the power supply. So I can measure the voltage that we get across that capacitor. I have a nice little breakout board that I made. Kinda. Let me get you to zoom in on this. Just a little bit of perf board that I completely mutilated when I cut it. And I put some pin headers on it. Ow! Holy crap. Okay, I'm bleeding. That's fine. And, yeah, so now I can stick this on a breadboard, which is good. Very good. And that should help break out the signals. Don't mind the blood. That's fine. It's fine. Only hurts a little bit. We're good. Okay. Actually, no, it doesn't really hurt at all anymore. But, yeah. That's okay. My hands are covered with scars anyway. So yeah, this should be it. We're going to try to reassemble it. And get this situated. Okay, this is going to be difficult. I have to avoid this little cutout here. Kind of bend these wires up. There we go. Make sure everything gets lined up. Now, what I don't know is if the LCD is going to appreciate, or that zebra strip conductive, rubber conductive thing is going to appreciate those wires being in there. And we'll see if it's not really the right screwdriver I should be using. I should be using the next size up. We'll see if we make good contact with that. Now, I am going to be missing a screw because I wasn't thinking when I put these wires through there. I could redo that. Yeah. I think it'll be alright. And these two are the most important because that applies the pressure to that conductive strip. So that will drive the LCD, and I'm not gonna. It's like 9 o'clock at night, and quite frankly, I'm ready to go to bed. So I'm not going to get my oscilloscope out of the closet and set all that up, but I am going to just put this back together. And we will see if we get any fireworks tonight. Should be fun. I didn't really... I gotta watch out for that. I didn't really modify this at all to... I'm bleeding pretty good there. Look at that. I didn't really modify this case at all to allow for the wires to come through. But we'll gently put this together. You know what? Maybe I do want to make some cutouts for these wires. Hold on a sec. I do have my X-Acto knife right here. And I'll very carefully modify the case just a little bit. You know, maybe there's a better... Yep, I have my box cutter. A better blade to be doing this with. We'll just notch out some bits of the plastic case. You won't even notice it from the outside, to be honest. Up, up, up. Okay, that's pretty good. I'm gonna cut down on the... Cut some ways into here to let the wires poke through. That should be good. And very carefully score the plastic this way. Right? Make sure you can see that. Okay, and we're just going to snap that off later, so that's going to be fine. I'm not entirely comfortable doing this, though, with the blade so far away from my hand. I mean, like this, right? If I'm doing this, at least I can't cut myself, right? That's the whole point of holding it like that. And just try to grab this like that. Actually, we managed to cut all the way through that. That was pretty impressive. Okay, so we cut two little notches in the plastic case there. I'm going to try to get all of the wiring through that. Okay. gently now. Gently. Poke all that through there. Okay, cool, cool. Put the screw in, and there we go. And I'm going to call that good. Yeah, none of the wires are pinched. Everything's cool, and if we undo this mod later, then we're not going to have any problems. Getting the son of a gun. Yoink. Okay, careful not to strip out the plastic, because it is just screws into plastic. And you don't want to strip those screws out if we can avoid it. And there we go. Okay. Put this in its proper place. That's still hot, but it's off. I'm going to unplug it because I need that. I need this. Alright. Let's plug this in. And I wonder if there's going to be any fireworks. What do you think? Place your bets now. Get that switch out from under the wires. Woo! Look at that. Works just fine. Plug in our load. Get that polarized plug out of the way. Turn it on. Let's do watts. You can see that there. Turn it on. Takes a couple seconds to update. 190 watts. Okay, cool. That's working fine. It's, what is that? That's hertz. Do volt amps. Oh, that's power factor, sorry. We'll do volt amps and watts are the same because power factor is 1. That makes sense. Okay, so everything's working fine. Except now that I have all these wires coming out, I have a nice little breakout board here and on my breadboard. So I can actually snoop these signals and get some information out of it. Cool beans.